Today we're going to talk about SN1 reactions. And just as a reminder, an SN1 reaction is a type of substitution reaction. And it represents a specific mechanism. A substitution reaction is of the general category where we have a substrate with a leaving group, and we'll have a nucleophile present, and the nucleophile might be neutral or negatively charged. If it's neutral, it'll be partial negative or full negative charge. And the product will be the substitution of the leaving group for the nucleophile, and then the leaving group having left. And depending upon the structure, the leaving group might have a negative charge or it might be neutral, typically with an atom with a partial negative one. The difference between SN1 and SN2 is how the reaction works in terms of the mechanism. So SN1 means nucleophilic unimolecular substitution. And it's unimolecular because the rate determining step is heterolysis, where this occurs. So we end up with a carbocation, and this is going to be the slow step, also known as the rate determining step. And the reason it's the slow step is because we are making a carbocation intermediate, which is going to be a pretty unstable intermediate in general. The second step in the SN1 mechanism is coordination. So this is where the nucleophile, either, again, negative or partial negatively charged, but definitely having a lone pair on it, will undergo coordination, and then we end up with the new nucleophile attached in that second step. So the one means unimolecular, and it's because of this particular rate determining step. Notice that it is a two-step mechanism. Here, the rate law for this reaction, because this is our rate determining step, will be the rate constant, which would have to be experimentally measured, times the concentration of the substrate. And that's because that's the only species present in that rate determining step. The nucleophile doesn't come until the second step and is going to react pretty quickly with our carbocation because it is a high energy intermediate. So this means you could double the concentration of the nucleophile and it would not, or half the concentration of the nucleophile, and it would not change the rate of the reaction. Only if you change the concentration of the substrate will it change the rate of the reaction. Okay, so next let's talk about, now that we have the mechanism itself down, let's talk about one thing that we have to be on the lookout for in terms of the SN1 mechanism, and that is this carbocation. So sometimes that carbocation might be not necessarily the most stable one that could be formed, so we need to check for rearrangement. So an important step in doing an SN1 mechanism is always to draw that carbocation intermediate and check for rearrangement before trying to determine what the product might be. I definitely will be looking to see that you can do a rearrangement reaction. And so it's definitely something that you always want to check for, because I will be testing for that. So sometimes it's heterolysis coordination. Sometimes if there's a rearrangement, it would be heterolysis followed by rearrangement. And then followed by coordination. The other thing that can happen with an SN1 mechanism is sometimes our leaving group is something that, like an alcohol, for example, and that's not going to be a good leaving group on its own unless we're in pretty strongly basic conditions. So sometimes what happens first is that we might have a proton transfer where we have some sort of acid present. And what that's going to do is it's going to make it so that the leaving group can be something like water, something neutral. So if that were to happen, you might have a proton transfer before the heterolysis occurs. And then sometimes if the nucleophile is a neutral compound, which it often is with SN1, we might have a proton transfer at the end of the reaction because we might have a positively charged molecule after the coordination step.